Okay, so let's talk some more about what the unit circle is and why it's so important in trig. So I'm going to try and draw and explain the whole unit circle. I'm going to try and make a pretty big circle. Of course, unit circle means the radius of the circle is 1, so this, the x-axis, here's the y-axis, this is 0, 1, this is negative 1, 0, this is 0, negative 1. Now the unit circle, really the purpose is to really help us find the trig values of our special angles, all right? So that's really the big use of the unit circle. It gives us a very simple and easy way to find the trig values of our special angles. So let's go ahead. But you know what? Special angles are not only the angles found in quadrant 1. It's not just 0, 30, 60, 90 degrees. We also will have special angles all the way around the unit circle. And by that I mean, let's go ahead and mark. So let's start here. 0 degrees, 0 radians. We know up here is 90 degrees. And we know it's pi over 2 radians. Over here, 180 degrees and pi radians. Down here, 270 is 3 pi over 2. Now if I go back here, if I go all the way around the unit circle, if I look at the angle all the way around the unit circle, I will have gone 360 degrees or 2 pi radians. All right, we've discussed that before. If I start here and my angle is all the way around the unit circle, I would have gone 360 degrees or 2 pi radians. Now the other special angles are halfway between, we call that 45 degrees. Turns out radians is pi over 4. So 0 to 45, 45 to 90. If I go 90 and add 45 more, I'm right here. That ends up being 135 degrees. Now here's what's interesting. What is this in radians? The nice thing is, I can look over here, and my denominator is going to be the same, and I'm going to have a pi up here, and now I have to figure out, I'm going to have some number in front of the pi. So here, it's really a 1. Over here, it turns out it's 3. 3 pi over 4. Now if I go down here, I add 45 degrees to 180. So degrees, it's 225 degrees. What is my radian? Once again, it's pi over 4, but the number in front now here is 5 pi over 4. Finally, go to my fourth quadrant. If I add 45 degrees to 270, it's 315 degrees. What's my radians? Just like this, it's pi over 4, but now I put a 7 in front. 7 pi over 4. And what's also interesting is, now let's look at the actual x and y of this point. For a 45 degree or a pi over 4 angle, I know the x and the y are identical. Square root of 2 over 2. The nice thing is, now if I go to my 135 degree or 3 pi over 4 angle, the second quadrant, you know what I do here? It's the same numbers. The only thing that's different might be the signs. And this is where you use common sense. Look at this point here. This point here is the x value of this point, positive or negative. Well, look at my x. I'm over here. My x is negative here. So I just simply put a negative sign. And now my y for this point here is y positive or negative? Well, obviously y is still positive. So this point here is actually negative square root of 2 over 2, square root of 2 over 2. I do the same thing here. The numbers are the same all the way around. Square root of 2 over 2, square root of 2 over 2. And then I ask myself, well, if I have this point here, for this point here, is x positive or negative? Well, obviously x is negative. And then y, what is y of this point here? Well, it's also negative. Therefore, in the third quadrant, I've got negative square root of 2 over 2, negative square root of 2 over 2. If I go to the fourth quadrant, oh, I should have wrote this inside. 315 degrees, 7 pi over 4. What is this point here? Once again, the numbers are the same. The signs, x for this point, it's positive. Y is negative. So that point is negative square root of 2 over 2. I mean, it's square root of 2 over 2 and then negative square root of 2 over 2. So really, you know what? Once you know the x and the y of the 45 degree, you really know the x and the y of those other 3 points, because they're all the same except for the signs. Now, let's look at what happens the rest of my special angles. Here's my 30-degree angle, which is also pi over 6. Here's what you have to remember. You have to just memorize that the x of this point here is square root of 3 over 2, 1/2. Now, if I do this same point, so here, 30 degrees up here, how about I go here and I move 30 degrees up here? So I get 150 degrees. Now the interesting thing is for radians, once again, it's just like this one here. I'm going to have a 6 on the bottom and a pi on the top. And as it turns out for this, it's 5 pi over 6. And the nice thing is, both the numbers here are going to be the same as over here, except for the signs. Right here, I know the x is negative, so I put a negative here, and this point is negative square root of 3 over 2, 1/2. So if I keep going, so each of these points are like 30 degrees from the x-axis. I move 30 degrees up here, here I'm 30 degrees. So if I go this direction 30 degrees, I'm at 210 degrees, right? 180 plus 30. Now, what's radians? Once again, same pattern. It's pi over 6, except now I have a 7 here. How about the x and the y? It's the same as these 2 points here. Square root of 3 over 2, 1/2. Except now they're both negative, right? Because in this third quadrant, both x and y are negative. And finally, if I move 30 degrees from here, that's 330 degrees. What is it in radians? It's going to be pi over 6 again, but now it's 11 pi over 6. And what's the x and the y? It's the same as the others, square root of 3 over 2, 1/2, except now only the y is negative. And there's one more special angle. Remember the 60-degree angle is right here. Now in terms of radians, it's pi over 3. Now the nice thing is, what's the x and the y? If I remember this one down here, to get the x and y here, I just flip them. So the 1/2 is the y here, the 1/2 becomes the x. The x was square root of 3 over 2, that becomes the y. So that's a pretty easy way to remember this one. And now, if I'm 60 degrees, or I can think of it as 30 degrees from the y-axis, I can go over here, and this would be 120 degrees. And what's the radians going to be? Once again, just like this here, it starts out with pi over 3, except in this case I put a 2 in front. What's the x and the y? It's the same as here, except for the signs. So hopefully you can start to see a pattern. If I go down here, if I move 30 degrees from the y-axis, it's like 240 degrees. What would my radians be? I know it's going to be a pi over 3. In this case, I'm going to put a 4 here, 4 pi over 3. I know the x and the y are going to be the same numbers, 1/2 square root of 3 over 2, except now they're both negative. And the last one, I move 30 degrees over here. Whoops. So that's a 300 degree angle. Once again, pi over 3. 5 pi over 3. Once again, 1/2 square root of 3 over 2. In that case, the y is negative. All right, I did this to show you really all you do is once you know and memorize sort of these 3 points in the first quadrant, it's very easy to get all the rest. And I'm just telling you now, you really need to memorize. You need to be able to recreate and create this whole unit circle by yourself, because you're going to use it over and over again in the homework and more importantly on the test. For instance, on a test, you may have a problem where you're asked to find the sine of 2 pi over 3. What you do is, in your mind, you go to unit circle and you go figure out the 2 pi over 3 angle. So it turns out it's this one right here. Since I'm looking for the sine, then in your head you say, okay, at this point here, what's the value of y? The value of y is square root of 3 over 2. You're done. You may be asked for the cosine of 3 pi over 2. To use the unit circle to find that, you first go find your angle, 3 pi over 2, which is down here. Then at that point, the cosine is the x value of that point. Well, this point is 0, -1. What's the x? It's 0. So cosine 3 pi over 2 is 0. What if I wanted the sine of 7 pi over 6? What do? You go find this angle on your unit circle. 7 pi over 6 is right here. And now since I want the sine, you go find the y value of that point, which is -1/2, and you say the sine of 7 pi over 6 is -1/2. For the next few weeks, you're going to have to be knowing right away the trig functions of these special angles. You just have to know it. And the easiest way that most of us have found to know those special angles is to come up with the unit circle. Now here is a nice version of the unit circle, and I will send you the link to this so you can print it out. So you notice here are all your angles in degrees, your angles in radians, and the x and the y of each point, all the way around the unit circle. Now another reason why the unit circle is very helpful is because you will then also have problems like this. They may say, what is the sine of 390 degrees? Easiest way to do it, in your mind or write down, you think of your unit circle, and you say, okay, where on my unit circle is 390 degrees? And then you realize the unit circle, one time around, right here, is 360 degrees. But you need 390 degrees. Well, all you do is, one trip around was 360. I need to go 30 more degrees. So you go 30 more degrees to right here. What you're really looking at is the sine of a 30-degree angle. In other words, the sine of 390 degrees is really going to be the same thing as the sine of 30 degrees. Because once you start going around the unit circle, you just start repeating yourself. And now the sine of 30 degrees, in your mind, see, I've memorized the unit circle, so I think of the 30-degree angle. Since it's a sine, I think of the y value. I know in my head, a 30-degree angle is square root of 3 over 2, 1/2. And I say, okay, so it's 1/2. The sine of 390 degrees is 1/2. How about the cosine of 11 pi over 4? So here's angle in radians. What you'll quickly realize is, what is one trip around the unit circle? One trip around the unit circle is 2 pi. If I convert that to where I have a denominator of 4, 2 pi is the same thing as 8 pi over 4. So one trip around the unit circle, I've gone 8 pi over 4. My angle is 11 pi over 4. So that means I go one trip around the circle, and how much farther do I have to go? Well, I still have to go 3 pi over 4. So I go one trip around, and then I go, let me do it like this. So one trip around is 2 pi, or 8 pi over 4. I still need to go 3 pi over 4 more. Three pi over 4 is right here. So you go all the way around once, and you go 3 pi over 4 more, and there's your 11 pi over 4 angle. Although really, this angle here is 3 pi over 4, so really cosine of 11 pi over 4 is going to be the same thing as cosine of 3 pi over 4. 11 pi over 4 and 3 pi over 4, these are called coterminal angles. Coterminal angles start and stop in the same place, right? How about I look at pi over 4? There's a pi over 4 angle. And then I look at 9 pi over 4. 9 pi over 4 is 8 pi over 4 plus pi over 4. 8 pi over 4 is 2 pi. If I want to draw a 9 pi over 4 angle, there's 2 pi, and then I have to go pi over 4 more. So you can see, for pi over 4, I started here, and I stopped here. For 9 pi over 4, I started here, and I stopped here. The start and stop are the same place. Therefore, 9 pi over 4 and pi over 4 These are called coterminal angles. Let's talk about, actually, I never finished this problem here. Let me quickly finish it. So we decided cosine, we find 11 pi over 4 is the same as 3 pi over 4. So the cosine 11 pi over 4 is the cosine 3 pi over 4. What's the cosine 3 pi over 4? In my unit circle, I say for 3 pi over 4, I know my point is negative square root of 2 over 2, square root of 2 over 2. Since it's cosine, I want the x value, so therefore I know it's negative square root of 2 over 2. And I've got it. So you're going to have a few problems where they may give you a negative angle. So how about they ask you for the cosine of negative 60 degrees. Now in the homework, sometimes I use this phrase, use the even odd properties. I wouldn't worry about that. I'm just going to simply go and find my negative 60 degree angle on the unit of circle, and I'm good to go. So what would that mean, a negative 60 degree angle? Remember, counterclockwise means positive angles. So how about negative angle means you go clockwise. You go this direction. So you start here. If I were to go all the way here, this would be like negative 90 degrees. So negative 60 degrees is right here. But when I think of my unit circle, negative 60 degrees, this is the same as 300 degrees, right? Because it's 270 plus 30. So these are the same. So all I do is I think to myself, well, for a 300 degree angle, what's my x and my y? Well, I know the x is 1/2. The y is negative square root of 3 over 2. Since I want the cosine of negative 60, I want the x value. So I say it's 1/2. One more. How about they say the sine of, how about something crazy like 21 pi over 2. So first I have to figure out where this angle is on like my unit circle. I know I'm probably going to go round and around a few times. As a matter of fact, 2 pi is actually 4 pi over 2, right? So 4 pi over 2 is one trip around the circle. So if you think about this one, you got 4 pi over 2. 8 pi over 2 would be 2 trips around. And you keep going. 12 pi, and then 16, and then 20 pi over 2. That's 5 trips around. And then we're finally close to this one. So really you could say 21 pi over 2 is like 20 pi over 2 plus pi over 2. So really we go around in a circle 5 times. We go around 5 times, and then we get to 20 pi over 2, and then we have to go another pi over 2. So basically we're sitting right here. Since you want the sine of it, we say, well, what is this point here? This point is 0, negative, or 0, 1. The sine is the y value. So the sine of 21 pi over 2 is 1. All right, in summary, the rest of this class, or a big part of it, you're going to be asked all the time for trig functions of these special angles. They're going to say, what's the tangent 5 pi over 3? They may ask you, what's the cosecant of 11 pi over 6? They may say, what's the secant of, the secant of 250, not 215, how about, what's the secant of 210 degrees? The way we're going to determine these is by, in our mind, we know the unit circle. First of all, I'm going to show you how quickly, hopefully, I can do this because I've learned the unit circle. Anytime I have a tangent, sine over cosine, sine of pi over 3. In my mind, I'm going to go find the 5 pi over 3 angle on my unit circle. So in my mind, I'm remembering 5 pi over 3 is right here. And once I find that point, I remember my x and my y. 1/2 negative square root of 3 over 2. So therefore, the sine of 5 pi over 3 is negative square root of 3 over 2, because the sine is the y. Cosine is the x, 1/2. Boom. Tangent of 5 pi over 3 is negative square root of 3. Cosecant of 11 pi over 6. Cosecant, first I go find 11 pi over 6 on my... What I'm really going to do is I'm going to find the sine of 11 pi over 6, and then I'll flip it to get the cosecant. So let's first find 11 pi over 6. You know where 11 pi over 6 is? It's right here. And beyond that, then I have to remember what the x and the y are of this point. And I remember the x is square root of 3 over 2, and the y is negative 1/2. So the sine of 11 pi over 6 is negative 1/2. Therefore, the cosecant, I have to flip this. Cosecant's negative 2. All right, I determined this from the unit circle. Last one, the secant of 210 degrees. I'm going to really find the cosine of 210 degrees and then flip it. 210 degrees. I'm going to go find that on my unit circle. 180 degrees, 30 more degrees is 210 degrees. I remember the x and the y of this point. X is negative square root of 3 over 2. Y is negative 1/2. The cosine, negative square root of 3 over 2. The secant, you flip this, so the secant toward 10 degrees is negative 2 over square root of 3. So that's the power of the unit circle. All these kinds of problems, most of the problems in this class from now on are going to be some of these special angles. And you're going to use the unit circle to go find your angle. And then once you find your angle, you remember the x and the y of that point. And once you do that, you know your sine and cosine, and then you can find whatever else you need.